Hello guys, how are you doing? Can you hear me?
Hello, yes, we're here. This is Candace.
Candice, how are you?
I'm well, thank you. How are you?
Good. What's your last name, Candice?
Young.
Yeah, I think I'm seeing your name as iPhone. That's why.
Good morning, everybody.
Yeah. All right.
Morning.
Everybody's here now. Only a few people.
Can y'all hear me?
Yes, loud and clear.
Yeah.
Oh, I'm
Yes.
Good morning.
Good
How are
morning.
you guys? I've seen Sandra's.
Good morning.
How are you today? All right.
Good.
I'm
It's a
well.
sunny day.
Good. I couldn't make it to the campus, so something came up. I have decided to do this instead of not doing the class at all. Let's do it remotely. So today we finished probability on Monday. Now we can now go to a new chapter, which is the probability distributions. If somebody's coming in. Okay, give me 1 minute. Let me put that person's name down. I give these names. I never had this name before. Oh, I see it. All right. So now we are now in new chapter called probability distributions. I gotta close some pages. Too many pages here. Okay, let me try it again. You can see the screen. Am I right?
Yes.
Yeah.
Good. Wendy. Yeah. Wendy. Yeah. All right, got it. So when I say or when we say probability distributions, we are referring to the distribution itself and the corresponding outcome or probability. Let me put it this way. We are referring to the random variables, the values that we can assume and their corresponding probabilities. So let us start with, because I say that random variables, their values, and their corresponding probabilities. So because of that, I will start with random variable, because that's what probability distribution is about. The probability distribution is about the random variables and their corresponding probabilities. So let's begin with random variables then. It says a random variable simply means, as you can see from the screen, any variable that have values that are determined by chance. Excuse me. They have values that are determined by chance. Example, a dice. You know, a dice, when a dice is thrown or tossed, the outcome can be 1, 2, or 3. I mean, 1 showing up, 2 showing up, 3 showing up. So all these things are random variable. We have no control over that. We have no control over what number will show up when we toss the dice. For example, number of Morgan State students, number of siblings they have, we have no control about that. That's an example. I mean, if you know anybody that go to Morgan, they can have 1 sibling, 2 siblings, you have no control over that. the time the bus arrive at the bus stop, things like that. They might say that the arrival time is 10 a.m., for example, but sometimes they arrive at 10:15, 9:59. You know, those we cannot control. So the variables whose values are determined by chance are what we call random variables. Now, we have two types. We have the discrete random variable. Now, the discrete random variable consists of the finite or infinite number of possible values, but they can be counted. We can count them. That's the main characteristics of discrete random variable. They are countable. For example, number of people who are jogging at Patterson Park, for example, we can say one person jogging, two persons, or two people jogging, three people jogging. You cannot say 1.5 person jogging because you don't count them. Number of eggs a hen lays in 1 week. 1 egg, 2 eggs, 3 eggs. You cannot say 1.5 eggs. So they are counted. Number of telephone calls received after a TV commercial. That's another good example of random variable. I mean, discrete random variable. They can be counted, but continuous random variables cannot be counted. This one can be measured. For example, height, temperature, voltage, age, and so on. Now, which brings us to discrete probability distribution, which is my main topic today. So a discrete probability distribution consists of values that a random variable can assume and their corresponding probabilities. That was my first statement. The values that random variables can assume or can take and the corresponding probabilities is what we call the discrete probability distribution. I mean, there are different types. For example, for us, we'll be looking at binomial distribution and Poisson distribution. Now, Poisson distribution, we will not cover Poisson in this class. Give me 1 minute. So one of your students says having problem. Give me 1 minute. What's 1 minute? Let's click on the link I provided yesterday.
Did you say we discussed Poisson distribution?
No. It's not in the syllabus, so I'm not going to cover it. We look at only binomial, and binomial, we'll do binomial next week. Today we will focus only on the introduction to discrete probability distributions. This student is having problem joining. Let me see. They have what you need to do. Your classmates are already in. My classmates. My classmates. All right. So we'll be focused on next week. We'll cover binomial, and I will introduce this one, normal distribution, which is a type of the continuous probability distributions. Now let's start with this one. Just the introduction to discrete probability distributions. I will use an example. Look at this dice here. It says construct a probability distribution following a single dice. So to do that, make a table like this form. Make a table of this type. So for the dice, each outcome, dice have 6 sides. You know that already. Each outcome has a probability of 1 out of 6 chances. I mean, for example, let's look at this outcome 1 showing up when you toss this die. The chance will be 1 out of 6. For 2 showing up is also 1 out of 6. 3 showing up is 1 out of 6 chances. Okay. 4 showing is 1 out of 6 chances. 5 is 1 out of 6. 6 1 out of 6. So that means that that is actually you are done. You say construct a probability distribution for rolling a dice. Remember the definition. It consists of the values a random variable can assume and the corresponding probability of those values. This is the value they can assume. This is the corresponding probabilities. And that's it. You answer the question. So so we have the distribution right here. So you get the values and corresponding probability. Let's look at another example. Before I do that, any question on this one?
So all they're asking for is the probability of that single outcome.
Yeah.
That's it.
Then for that outcome, you have the corresponding probability. That is what the discrete probability distribution is talking about. The outcome and the probability. That's it. Now look at this one example here. This one, they ask you several questions on this one. It says,
I have one more question.
huh?
Why didn't we do the total?
Not yet. We don't need it now because the question says only to construct. I mean, if you do it, nothing wrong with that. If you want to do it, I can just do it right here. So that will be, but once you get the outcome and their corresponding probabilities, you have answered the question. If you want to do the total, we can have 1/6 plus, I gotta make this bigger. Okay, 1/6 plus 1/6 plus 1/6 plus 1/6.
We couldn't just do 1/6 squared.
No. It's not the same. If you want to do it that way, this one is addition. Remember, 1/6 plus if you are doing multiplication rule, then you can do squared. 1/6. How many of them we have? We got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So that means 6 now, right? Equal 1. They have from your algebra class. If they have the same denominator, you just add it in the numerators. 1, 2, 3, 4, 5, 6. That's 6/6, which give us 1. So answer here is 1. That's total 1 right there. And then, any question on this?
No.
Okay, good. Now look at this one. This one, they ask you three different questions. It says, during the summer moon, this is the application, kind of like an application to that. Application of what we just did. It said, during the summer months, BMZ Rental Incorporated is a rental agency. They keep track of the number of chainsaws it rents each day during the period of 90 days. The number of saws BMZ rented per day is represented by the variable X. The results are shown here. So it's a number of days, and then number of chainsaws. I'm gonna make this number, right, of chainsaws rented. Saws rented. Okay. Let me expand it. That is our X. That's the outcome. Outcome means number of chainsaws they rented. Let me start saving this on the desktop. Desktop. So I'm gonna. You guys want this, right?
No,
Yeah.
we do.
Sure. All right.
I'm trying to say, I'm over here, couldn't find the mute button. Yes.
Miss Wendy, that sound like you. Is that you?
That's me. Good morning, Professor. Good morning, everybody.
Good morning. I kind of I'm having a feeling that since we started this probability topic of probability that you have been following, Miss Wendy.
Yeah, and my awesome classmates, and we've teamed up and we've been getting some studying going, so that's helped out a lot too.
Oh, that's good. That is great. Study group is good. It helps. Okay, good. So now we have see the number of chances of the results. It says these are the results. Say compute px. That means compute the probability of x for each of the x's here that we have here. Then it says construct a probability distribution and then graph for the theta. So I'm going to do all this in one table. I'm going to use one table to do that. And then, yeah, I'm going to use one table. Let me copy this. Answer part B, part A and the part of part B in one table. Then we can draw the graph. Now let's do it. I'll put it here. Now for the probability distribution, we have the outcome and the corresponding probability. So I'm going to add more columns here. Okay, so I'm going to add more columns here. Okay, add something here. Okay, add another one here. Hope it will allow me. Good, that takes care of that. Now I'm going to extend it. So the first thing we do is to find the correspond. We have the outcome already, right? We have the outcome. We have number of days. Okay, let's add the number of days. Oh, make sure you are seeing this. You guys are seeing this too, right? Sure, you are seeing it. Let me get
Yes,
back.
yes, we can see.
Oh, good, excellent. Let me write the days down so I can add them. I got 45.
Professor, real quick though, you started saying something. You said we already have the outcome because you said first thing you need to do is find. Then you said we already have the outcome. So
Yeah, these are the outcome here. Number of chances or the rented.
Yes, you said we have that. So that would be the very first thing if it wasn't there. But since it's there, what's the next first thing?
Yeah, next thing, because the question was, it said compute px for each outcome. The outcome are represented by x. So that ps means probability of x. So you want us to compute that first. So I'm going to put that here, px. Of next thing, px. That is the probability of x. So then after that, we can now say construct a probability distribution. Okay. So I'll have all of them done in this one table here. Now, since we have the outcome, then to be able to calculate px, we need the total of this. Because for 45 days, they rented no chainsaws. For 30 days, they rented only one. For 15 days, they rented two of them. So let's get the total rented here. We're going to use the calculator to get that. Calculator, we have 45 plus 30 plus 15. It's 90. So this happened in a total of 90 days. So 90 days. So let's calculate each of these probabilities. The first one we need to calculate is the probability of that they rented no chainsaws. I mean P of 45 of 0. The chance that they will not rent any chainsaw is 45 out of 90. Out of 90. See? So 45 out of 90 to be got 45 divided by 90. 0.5. 0.5. 0.5. So I'm going to put it right here. 0.5. Now, they rented only one chainsaw. Okay. only one chainsaw. Is gonna be the probability of one chainsaw. P of one chainsaw. Gonna be, so for one chainsaw, we'll have a number of these 30 out of 90. Out of 90. So I'm gonna go to a calculator and get that. 30 divided by 90. Got 30. Okay. 0.333. So 0.333. That means 0.33. Since we're using two decimal places here, 0.33 should be good enough. 0.33. 0.33. I'm gonna put it right here. Then they rented only 2 chainsaws. I'm gonna calculate it under here. The probability for 2 chainsaws equal. Okay. For 2 chainsaws. Maybe that one we have 2. Is she still having problem? Is she having this problem? She says she can't access her canvas. Right, is helping me to log in. Just give me a minute. Let me see. Please send me the link here. Say send me the link here. Okay, let me send the. She says she cannot access the canvas, so let me send the link to her. Just give me 1 minute. Let me. She's having problem logging in. Let me see if I can send the link through. Okay, let's see. Okay, I sent it from here. Yeah, that's what that's it right there. I'm gonna join it, take it from here. Okay, let me use this. See if I can she can get it from here, from me, from here. Okay. I'm gonna go over here. My mind. Okay. Let's send it to her. What's wrong with her canvas? Yeah, I'll send it to it. So, yeah, I think she can access it now. Log out. Okay. Send it. I have sent it to you. Okay, she's coming in now.
All right, so you want us to log off?
No, she's coming in. She's coming in now. She couldn't access her canvas, so she's been trying. So she want me to send it into her to remind. So I did. You guys are good. I said it because there's a student who is struggling to come in and she couldn't access her canvas. So yeah, we are good. It's just for her, and she's in now. Let me check her name. Okay. Miss Mosey, are you in?
Yes, Professor. Thank you. Thank you.
You're welcome.
Thank you.
Welcome. So now look at it now. So for 2, there's 15 out of 90. So we gotta do 15 divided by 90. So have 15 divided by 90.16. But 17 rounded, you know. What is it? 0.1666. So 0.17. So you got 0.17. 0.17. So we go there and put 0.17. 0 point. Okay. Now if you do the sum of this, we're gonna have
It should come up to 100, right?
yeah, you're gonna come to 1 or 100%. So you got 0.5 plus the other one is 0.33 plus 0.17. And that will give you you write it down, write them down. 0.5 plus 0.33 plus 0.17. So we can go and complete it here. We got 0.5 plus 0.33 plus 0.171 plus 1, which is like I say 100%. 1.00 which is 1.00. So we'll answer part A. Now part B says, before I do part B, any question in part A? Any question? Okay, good.
No,
Good, good.
no.
Good, good.
No.
Excellent. So let's do part B. Part B say construct
No.
construct a probability distribution and then graph the data. It's already here. See the outcome. This is the corresponding probability. So I can just let me just bring it down and place it here, because a probability distribution is nothing other than the outcome and the corresponding probabilities. You know, that is the distribution right here. You see the probability distribution. So the probability distribution is shown below. Okay, and see the number of chancers and the corresponding probabilities. That's what we call the probability distributions. Now, any question on this?
So what about the graph?
No, remember we just did first one. This is just one part of the second part B. But I want to see if there's a question before we do the last part, which is the graph. We do that one separately. So any question on this one? Any question?
Why did we take the number of days out the chart?
Because it's not a part of the probability distribution. Remember, when I did this one, you can see the outcome and the corresponding probabilities. And remember when I said here that a discrete probability distribution, that a discrete probability distribution consists of the values a random variable can assume and the corresponding probabilities. So the outcome or the values and the probabilities. Here we are giving this so that we can be able to get the probabilities. Once we have it, we can now put it in the form of the outcome and the probabilities. Any other question? Okay, since there's no question, I can now make the graph. So these are outcomes. Number of chancers rented. Number of chancers. Okay, chancers that are rented. Chancers. Oh, excuse me. Rented as the outcome. These are X. And this place can be our PX, the corresponding probability, PX. So I can have 0 chancers rented, 0 chancers, one chainsaw, two chainsaws. Yep, these are probabilities. We got, it goes from 0.17 to 0.5. So make it down, bring it down a little bit. Okay. 0.1. So I'm gonna use that scale. 0.2, 0.3, 0.4, no, 0.5. Yep. Now I can just move this a little bit. Okay. That's good. Now I can put a graph. It's a line graph, matter of fact. So you're gonna number of px. Okay. Make it a little bit this way. Then I got okay. So number of chainsaw, the rentage, and their corresponding probabilities. Now for zero chainsaws, it's a line graph. I can even use a box to do it. So I can have a box for that. Okay, maybe it's a box. But zero chainsaws. I can, how many of them? 50. It's about 50. Right, that's there. Then see 0.5. So 0.5. But one chainsaw is 0.33. 0.32 should go, this is 0.3. Halfway 0.35. So 0.32 should be around this neighborhood. So I'm gonna, sit on that neighborhood. For one chainsaw. You know what? I think I messed it up. Okay. For one chainsaw, I'm gonna start from here so I can easily adjust it. One chainsaw is 0.33. So it's gonna be like here. Okay. Okay. Now I'm gonna adjust this so that you can, they have the same size. Then two chainsaws is 0.17. Gonna bring it closer a little bit. This should be, all distance. Two chainsaws is 0.17. This is 0.1 right here. 0.15 will be halfway. So 0.17 should be very close to 0.2. So I'm gonna put that. Okay. Very close to 2. Okay, then I got it. Yep. Got it. That's the graph right there. So any questions?
So so do you want us to draw it out just like you did, or there's another way that we could do it?
Aiming to draw this graph?
So you want us to draw the graph?
Yeah, that's what the question says, draw the graph.
Okay.
Say graph the data.
Okay.
So you can use your pencil and paper, or you can just use to draw it with the computer.
Can't we still graph it the other way like you showed us?
Like what?
By just copying data and then selecting the graph.
Yeah, you can try. You can use it. You can do it in Excel too. Yes, of course. You can do it in Excel. Put the number in, type in the probabilities, then highlight it, show the graph. That's step. Yes, sure. Any other question before we move to the next?
That's Professor. I have a question.
Yeah.
What do you select to make the lines to create the I missed that part. I tried to do that on my own on another assignment. I couldn't figure that part out. How to make the line, this thing that you just did. The line graph.
which part are you is are you
Well, we
referring to?
made the line graph just
the-
now.
Oh, we just
Yes.
did?
Uh-huh. Can you
Uh,
show me what you clicked on so that I can do that?
Oh yeah, it's right here. Click on insert.
Uh-huh.
Then you see how you have a, this
Shapes.
that, yeah, the idea you can now choose, and that you choose any of the shape. Like I'm choosing this box. Then once you choose that, you can now modify it however you want.
Okay.
You can decide to make it this way, or you can decide to make it up. You can just modify it however you want.
Okay.
Mm.
I got it.
Yeah,
And then I guess the other little lines, that's how you get the box with. Okay, got it. Thank you.
you're welcome. Okay, now let's look at the next concept. So the next concept is about, it says the two requirements for a probability distribution. How do we know that outcome and how do we decide that the outcome and the corresponding probability is a true probability distribution? How? First one is to we vet it using these two requirements. And that two requirement is, first one is that the sum of the probabilities of the sample space is 1, must equal 1. The sum of the probabilities of the sample space must equal 1. Okay, that's the first requirement. When you look at this, the first one we did, we added, and it's 1. If it's less than 1, then it is not a probability distribution. If it's greater than 1, then it's not a distribution. Look at the second one, we added and we still get 1. If it's bigger than 1, then it is not a probability distribution. And if it's less than 1, it is not a probability distribution. So it must
So
be
if it's just not, if it's just not 1, it is not the probability distribution. Is
Exactly.
that what you?
Yeah.
Okay.
If it's less than 1 or bigger than 1, then it's not. It must be
Okay.
equal to 1.
So it just needs to be just 1.
Yes. Yeah. I mean, when you add all the probabilities, yes. Now, second requirement is that the probability of an event, the probability of each event in a sample space must be between or equal to 0 and 1. That means it can never be negative. The probability of the event can never be negative. Let me put it this way. The probability of an event in the sample space, any event, can never be bigger than 1 and can never be negative. That's what it's saying.
So what if you get a negative outcome?
Huh?
What does that mean?
It can have a negative outcome. A negative outcome means that you don't have any outcome.
So you're saying that there's never a possibility that there's no way that something can occur.
Then if it cannot occur, then the probability is 0, not negative.
Oh, sure. Okay.
So now, let's see how to apply this. Look at this. It says determine whether each distribution is a probability distribution. Let's look at the first one. The first thing we do, look at the probabilities. None of them is negative. So let's add them. 1/5. Okay, remember this symbol represents sum. Remember, this is sum of px. That means sum of the probabilities. So that's what it means. So the sum of px equals 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. How many of them? 5 of them, right? Now 1, 2, 3, 4. Yep. That gives us 5/5, which is 1. So the answer is yes. Yes, because the sum of the probabilities equals 1. So that is answer is yes. Remember the question was determine whether each distribution is a probability distribution. Now let's look at part B. Part B says Tabi, we don't even have to do anything because one of the one of the probabilities is negative, which according to this rule, it can never be negative and it can never be greater than 1. So this one, we don't even need to do any work because it says this one is negative and this one is bigger than 1. So the answer is no, because one of the probability values is negative. And another one has a value that is greater than 1. See? Once you see that's negative and then you don't even have to do any calculation, just answer that it's not. Okay, let's look at part C. Part C says,
Can you go back to A really quick for me, please?
the first one.
Yes, please.
Mhm.
Okay, got it.
Mm.
Thank you.
You're welcome. So this one says, it's a PS. Okay, let's see. None of them have negative, so let's check it to see if it is a probability distribution. Have 1/4 plus 1/8. Oh, gotta make this bigger. Make it 1/8 plus 1/16 plus 9/16. So I'm gonna write this down so that you can check it, see if that equal to 1. I got 1/4 plus 1/8 plus 1/16 plus 9/16. Let's go and put it on the calculator. 1/4 plus 1/8 plus 1/16 plus 9/16. Say 1. So the answer is yes. Okay, yes. Because the sum of the probabilities equals 1. Okay. Now this one, none of them is negative, so let's try it. 0.5. Make it bigger. 16 is good enough. 0.5 plus 0.3 plus 0.4. So 0.5 plus 0.3 plus 0.4. I think I can have this on my head. 0.5 plus 0.3 plus 0.4. 1.2. So is this one a distribution? Is it? What do you think?
No.
No, yeah, because it's bigger than 1, right?
Right.
Yeah, no, because the sum of the probabilities is bigger than, is greater than 1. Greater than 1. So that is it, that's how you verify it. And you might be asked this question in a different form. Look at this one. See, it's a determine the required determine the required or missing value of B to make the distribution a discrete probability distribution. See, this outcome has a probability right here. This one have one, but this one doesn't have a probability. Instead, they put B there. How do we find B? Now, you already know that their sum must equal 1. If you remember, the sum of the probabilities of all the events in the sample space must equal 1. So once you have that in your mind, that means all you have to do here is to subtract all these answers from 1. So B becomes 1 minus 0.41 plus 0.02 plus 0.35. And that was the answer we're looking for. Let me write this down. 1 minus 0.41 plus 0.02 plus 0.35. Let's go and put it right in our calculator. So I got 1 minus 0.41. I think it's 41, right? Make sure. I wrote it down, but I wasn't sure what I wrote here. Yes, 0.41. 0.41. 0.41 minus plus 0.02 plus 0.35. 0.22. So B is 0.22. Any question?
No.
Okay, excellent. So now, at this point, we're ready to now discuss the mean, variance, and standard deviation of a probability distribution. Now, remember, we have done the mean, variance, and standard deviation before. Remember, that was I think it's chapter 2. Those are for frequency distributions. Now, we are doing the same thing for a probability distributions. Excuse me. So it will be a different formula. For a probability distribution, the mean is, of course, the same symbol mu, sum of x times the probability of x. For variance, delta square, which it will be sum of x squared times the probability of x minus the mean squared. Then the standard deviation is, as usual, is the square root of variance. Now, there's, this is the shortcut. I mean, I'm going to show you the shortcut method for doing this. Let's try this example here. It says here, okay. It says, Davis Williams is the president of Middle River Community Bank. Mr. Williams feels that each savings account customer has, on average, 3 credit cards. Excuse me. The following distribution represents the number of cards each people own. Say number of credit cards. And then they require the probabilities. So you can see that it says find the mean, variance, and standard deviation. And then is Mr. Williams correct? I mean, remember, he was claiming that each savings account customer have on average 3 credit cards. Is he correct? We can find that after we calculate the mean, variance, and standard deviation. So to do that, like I said, I'm going to show you the shortcut method. I'm going to use this table. I'm going to expand this table, make it at least 14. Okay, good. Now, so to do that, we need to get these columns. X, we were given X already. PX, they give us the us already, so we put them in. Now, this part of the formula, x times px, then s squared times ps, put together. We have them here, x times px, then x squared, then you got s squared times ps. So let us do s times px first. S times ps means this times that. 0 times 0.18 give us 0.00. 1 times 0.44 give us 0.44. 2 times 0.27. That one we have to look at this. That one on the on the calculator. So I'm looking for 2 times 0.27. So 2 times 0.27. 0.54. 0.54. 3 times 0.08. 3 times 0.08. Have 3 times 0.08. 0.24. 0.24. 4 times 0.03. So we got 4 times 0.03. 0.112. 0.112. Now for this part, x squared, that means you gotta square all these x's. So 0 square is still 0. 1 square means, of course, 1 times 1, which is still 1. 2 square means 2 times 2, which is 4. 3 square means 3 times 3, which is 9. 4 square means 4 times 4, which is 16. So now, we got this. So we need this to get this part, which is x squared times ps. That means I'm applying this with this one. So this times that. So 0 times 0.18 is still 0.00. 1 times 0.44 is still 0.44. And then 4 times 0.27. That's 4 times 0.27. That's the one I need to get. 4 times 2.27. Then okay, 4 times 0.27. 1.08. So I'm gonna go there and put 1.08. So we have next one be 9 times 0.08. 9 times 0.08. Again, got 9 times 0.08. Oh, 0.08. 0.72. So good and put 0.72. 0.72. And then 16 times 0.03. 16 times 0.03. Okay, 63. So I'm gonna do 16 times 16 times 0.03. 0.48. So I'm gonna go there and put 0.48. Okay, 0.48. Now we can now get our total. We need a total for this part. So excuse me, sorry. the total for this side and total for this side. So we can now add all this one. So I'm gonna write first one 0.00 plus 0. Okay, I mean, like the sum of this, it's gonna be 0.00 plus 0.44 plus 0.54 plus 0.24 plus 0.12. Okay, have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that will give us the mean. We add it. So we have, let me write them down. 0.44 plus 0.54 plus 0.24 plus 0.12. 1, 2, 3, 1, 2, 3, 4, 5. So let's go and add it. So we have remember this is the S times PS. So 0 plus 0.44 plus 0.54 plus 0.24 plus 0.12. 1.34. 1.34. We have 1.34 here. I mean, so mean is 1.34, which is approximately which is approximately 1 credit card. One credit card. See, that's 1.34. If you round it algebraically, is 1.3 is 1. Now, then the standard deviation variance now becomes equal. It states sum of x squared times PS minus mean squared. This is x squared times PS, the sum. Let's get the sum. And it's gonna be 0.00. This space will not be enough for it. Okay, let's see. Plus 0.44 plus, I'll make it make it at least 14. Okay, plus 1.08 plus 0.72 plus 0.48. And that will give us approximately equals, let's add all this, equals, let's add these numbers here. I got 0.00 plus 0.44 plus 1.08 plus 0.72 plus 0.48. So let's go and put this in the calculator. See what the outcome will be. We got 0.00 plus 0.44 plus 1.08 plus 0.72 plus 0.48, 2.72, 2.72. So I'm going to put that right there, 2.72. 2.72, which is what we have here, 2.72. The formula says sum of x minus mean squared, see? a mistake. It says, so S squared times PS, which is 2.72. 2.72. I put them there just to help me get the calculation complete. So I'm gonna make this 16 now. Okay. So this part here, sum of S squared times PX, which is at 2.72 right here. Say minus, see the minus sign, minus. So I'm gonna put minus, say the mean square. We have the mean as 1.34. So I'm gonna put 1.34 squared. So, adjust this. That gives us the answer we are looking for. 2.72 minus 1.34 squared. 2.72 minus 1.34 squared. Let's go and put this in the calculator. We got 2.72. 2.72 minus 1.34 squared. 0.9244.92. 0.92. So we got 0.92 as the variance, 0.92. Now the standard deviation, as usual, is always the square root of the variance. So I can't get the character from here. I'm gonna get it from the other workbook. The standard deviation, becomes standard deviation equal, and make it bigger. Make it okay, 16 equals the square root of variance. Okay, which is equal to the square root of our variance. If you recall, we got the variance here as 0.92. So that means square root of 0.92. Square root of 0.92. Okay. Oh, excuse me. Okay. Which is, let's go and get this from the calculator. 0.92 square root of 0.92. Okay, square root of 0.92. 0.959. 0.959. I mean 0.96 basically. 0.96. Okay, I'm gonna copy this and paste it in our main workbook. So we got the standard deviation. We have all our answers now. Okay, right there. So now part B says, is Mr. Williams correct? Remember, he was claiming that each savings account customers has, on average, see, average is the mean, on average, 3 credit cards. Well, our answer for the average here is 1.35, which is approximately 1 credit card. So that means he's not correct. No, he is not correct. He is incorrect. Because our mean, which is the average, equals average we got was 1.34. 1.34. Which means that I'm gonna copy it from here. It means that each savings account customer has on average 1 credit card. Approximately 1 credit card. That each savings account customer has on average approximately 1 credit card. 1 credit card. Are you guys sleeping? You look like you guys are sleeping. No, but I don't hear any voice anymore. Hello?
I'm not asleep.
We're
not
here,
asleep.
Professor.
Missionary,
We're right
you know-
here.
We're here.
Missionary, you know,
Listening.
I see, missionary, you know, I've seen you sleeping in the class. I just look the other way. I just look
You
the other
said
way.
you
Hey,
saw me
Professor,
sleep
we're
in
here.
class.
We're here.
Okay.
We're awake.
Okay.
Professor, you said you saw me sleep in
Yeah,
class.
I just looked the other way. You didn't know.
You did not see.
So you might be sleeping now. I will not know. And you say,
I'm
oh, I'm
not
awake.
I'm woke. We all full awake.
I just think everybody has their phones on mute, but we're all listening. We're very invested in this.
Absolutely.
Are you their lawyer?
Extra credit.
Okay, so I mean, since I mean, that means you are following. I'm happy. I'm happy. Very good. Now, let's do we still have we have a few. We can finish this part in the remaining time. Yeah, what you're gonna do is we continue from expected value. Now, expectation is where we apply this principle of finding the mean and the variance and the standard deviation of the probability distribution. How we apply it in real life. We call it expectation or expected value. Yeah, I'm gonna use the lottery for it, example, and I'm gonna use a real business for it. So when we meet on class on Monday, we do that, and I can then introduce the concept of binomial distribution. I would like us to finish I will finish it on Monday, finish binomial distribution next week. Yes. Yeah, we are getting there. We are getting there. Yeah, because
Yes,
if I start this one now, we will not be able to finish this before it's the time. Yeah. Okay.
Hey,
Having
Joe,
said
that's your favorite subject.
Huh?
That's Joe's favorite subject. You start talking lottery.
Well, you know, are you inferring that you don't buy the lottery at all?
No,
Listen.
my knees hurt. I work all doggone day. I don't play with my money.
You don't play. You don't buy it at all. Even one ticket.
No.
Really?
Well, I have purchased tickets because my father encouraged me to, but no, I don't play the lottery.
Oh, I buy it sometimes once in a while. You know, buy a ticket and then I pray. Yeah.
I lose a quarter, I'm
You
upset
never-
about that. So I
Yeah,
can't play
but-
with my money.
It's people get addicted when they have in their mind that they can predict it.
I don't like the
That's when they get
online.
well, that's when they get addicted. But if you know that that's why I always show it in my class. I say it is pure luck. Because if you want to use, I'll show you an example last Monday. The odds are so much against you as the player, you know, so much against you.
You showed us already.
Huh? Yeah, I showed it in class last time. Okay.
But y'all got gamble on the ocean, not online. It's a whole lot less cheaper. No taxes.
Where?
On cruise ships.
Oh, cruise ships. Oh. Oh, Mr. Joe, you're telling them how to dodge taxes or what? Oh my goodness. Mr. Joe.
This is for
You gotta pay your
entertainment
taxes, Mr.
purposes
Joe.
only.
Mr. Joe, you gotta pay your taxes.
This is for entertainment purposes only.
Anyway, guys, I see you on Monday, okay? Enjoy your weekend. Yeah?
Okay,
Yeah,
Thank you,
yeah,
Professor.
4th of July.
You
Have a
guys.
great
You
4th
too.
of July. Thank you. Have a
Enjoy
great
your
weekend.
weekend.
Oh, before
Thank
you
you,
go,
Professor.
you're welcome. Before you
Thank
go,
you, thank you.
don't go yet. Before you go, I want to show you this.
Okay.
I'm gonna upload this here. I'm going to upload this here. When you scroll down all the way to where we have the week 9 probability distributions. Oh, you're almost finishing. Yeah, I'm gonna this is gonna be. I'm gonna make it week 9. Are we week 9? Week 7, not 7, right? We are in week 7. No, come on, that was my mistake. Week 7, not 9. Week 7. to 8. It's gonna be week 7 to 8, week 8. Week 8. That's where I'm gonna place it. See here. So I'm gonna place it under here. Then I'm gonna record. This video is recorded, so I'm gonna put it probably in the announcement. I'm gonna put the video in the announcement, so you can watch.
I'm sorry, Professor, where are the where I always have a hard time finding them with the solutions. I'm not sure if I'm looking in the right place. Like for the one, like each week, and we ask, are you going to put the solutions in? You say you're going to upload them.
Yeah, right. Like this one, the one we finished on Monday, the probability is right here.
All right, I'm gonna look at it
under
again,
week
but
5,
some of them
you
I
see?
didn't see the solutions unless I downloaded something wrong.
Yeah, look at
Yeah.
here. Look, with 5 and 6, you gotta go all the way from here, right here.
Okay.
Click on this. That's where it is. Look at it. Now this one, I'm going to put this one here. Under week 7 to week 8, I'm gonna put it right here. Yeah, that's what I'm gonna put it. Okay, so that's what I want to go tell you. I see you Monday.
All righty. Have a
The
good
video is on
weekend,
the
everybody.
announcement. Yeah.
Have a
Thank you,
good night.
Professor.
4th of July.
Yeah, the same to you. The same to you.
Thank you, Dr. Oji. Goodbye.
See ya.
Sure.
Professor?
Yes, ma'am.
So I'm having trouble with my Canvas, and IT said there's a problem with it. So, but then they're still fixing it. So, is it possible for me to maybe because I haven't submitted classwork 6.
You haven't submitted classwork 6. Why? Because of the problem?
Is it classwork 6? Oh, let me see.
Classwork 6 was classwork
Yeah, the one that's due today. Yes.
yeah, I'm
I
looking for
can't
it.
log in. Yeah, the thing is I can't log in.
I think it's from your password. Maybe you messed up your password. What is it? Yes, this one. This is
Yeah,
one that is.
Yeah.
This is the
The
one, right?
classwork
This
6.
one here.
Yeah.
Classwork
Yes.
6. Yes.
Yeah.
You haven't submitted
So
it?
No, because I've been trying to log in and it's been giving me problems. So I've called IT and then they told me that there's something wrong with my account. So
Yeah.
they're still fixing it because I've been calling them.
Yeah, it's due today.
So that's why I couldn't.
It can still submit it today. It's not too late yet. It's gonna be from now till midnight, which is like 11:59. So you still have time.
Okay. All right. Thank you. I'll check it again and see if it's working now.
Yeah, no problem.
All right.
All right,
Okay.
guys.
Thank you, Professor.
You're welcome. Enjoy your week. Your week. Don't drink
You
too much
too.
now, Mr. Joe.
No,
Thank
sir.
you, Professor.
You have a nice.
Professor,
Yes.
make sure you share your barbecue on Monday.
No problem.
Have a nice 4th, guys.
You too. All right. Let me go.